Hello, good morning everyone. Hope all are doing well. Am I audible? Surinder sir, please unmute yourself. Our session coordinator is requested to please unmute yourself. Good morning, sir.
हाँ अब हो गया ओके ओके सो इट वाज सॉरी सॉरी मैं सोचा कि मेरा नाम क्यों नहीं दिख रहा है बस थिंकिंग हाँ 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 आई एम रेडी विद दिस इंट्रोडक्शन सो मैं हाँ गेस्ट को अच्छा इसमें आई हैव टू ओनली स्पीक और आई हैव टू स्पेयर द प्रेजेंट आल्सो मैं उनके विषय में केवल ब्रीफ एक बार आइडिया देना है ना उनको हाँ हाँ ठीक है दिस पेज आई एम हैप्पी ओके थैंक यू Hello, good morning. Your
Very good morning, sir. Our guest of this session, Dr. Samantha Hazarika, sir, has joined the session. I
yeah, yeah.
request please unmute yourself, sir.
Thank you very much. Good
Good,
morning.
good morning, sir.
Good morning, sir.
And I am Dr. Oti Mishra, and session coordinator of this your session on robotics, history, trend, and future directions. I welcome you here, sir.
Thank you very much. Thank you.
Sir, before we go ahead, I will introduce the speaker of the day. I'll be speaking few words about Dr. Shamanta M. Hazarika. He is a professor of mechanical engineering at IIT Guwahati and leads the Biometric Robotics and Artificial Intelligence Lab. His research interest is in rehabilitations robotics. This translates into interest in artificial intelligence, biometric robotics, and neurorehabilitations. Prior to joining IIT Guwahati, he was with the Department of Computer Science and Engineering, Tezpur University. He has been a veteran professor of cognitive system and neuroinformatics, University of Bremen, Germany. Professor Hazarika holds a BE in Mechanical Engineering from Asan Engineering College, Guwahati, India. MTech in Robotics from Center of Robotics, IIT Kanpur, India. He has completed his PhD in Artificial Intelligence from School of Computing, University of Leeds, England. I welcome you here, sir, for your valuable talks. Over to Professor Samantha M. Hazarika.
Thank you, Dr. Mishra, and good morning to all of you. I would now start my talk. Before that, I would love to stop my video so that we have a better bandwidth. So
Right, sir. Right, sir. Right, sir.
I will now start my talk. My talk is a very preliminary talk. So I would be talking on robotics. Particularly, we would be looking at the history, trends, and the future of robotics vis-a-vis as mechanical engineering. Now, one needs to understand that the story of robotics, whenever we are talking of a number of dreamers who had dreamed beyond their times. So when I am tracing the history, trends, and future direction of robotics today, I will be telling you the story of dreams and dreamers who really thought big beyond their times. And that is how this whole area has moved ahead. Now, this talk here that we are going to have a very short glimpse of is actually a chapter of a book. The book is called Introduction to Mechanical Engineering, published by Springer. And in that, me and my colleague, Professor Dixit, have a chapter called Robotics, History, Trends, and Future Direction. For people interested to know more in whatever I'm talking of and in depth, may kindly refer to that book. So, as I was telling you, robotics is a story of dreams and dreamers. In fact, the quest for artificial intelligence and robotics begin with dreams, as all quests do. And you can think of mythology, where you have seen people imagining machines and with human abilities. automata that move and devices that region. We have so many from the Hindu mythology as well, where we had flying machines, where we had supernatural humans. So these were emergent to have human abilities and abilities even beyond the human capability. Human-like automatons are also described in many stories and pictured in sculptures, paintings, and drawings. Now, possibly the one that's nearest to being recorded is in the book called The Politics by Aristotle. Nobody thinks of robotics and Aristotle at the same go. But here is what I am telling you, that the dream for robotics or something that could be automated was seen by Aristotle in his book, The Politics. And he had written this paragraph, which I am going to read for you now. For suppose every tool we had could perform this task at our bidding, that means as we request, or by itself, so it could be automatic, perceiving the ring, and self-move, they enter. So he was imagining shuttles in a loom that could fly to and fro, that is an automated weaving machine, and plucker play a lyre, that is an automated or a humanoid musician. And he said then master craftsmen would have no need of servants or masters of slave. And that is the society he was planning of or dreaming of when he was talking of robotics. So in here lies the genesis of what we should strive for, that technology of robotics and artificial intelligence, or any other technology for that matter, is to bring political equality, is to really remove the social divides that we have. And that's the story of dreams and dreamers. Are you able to hear my voice clearly? I would need a response now.
Yes, sir, you are loud and clear, sir.
Okay, thank you very much. Thank you very much. Okay, so Leonardo da Vinci, that's the second person who had sketch designs for a humanoid robot. And he had done it in 1495. So the genesis for robotics is not new. It lies in times of Aristotle and then carried forward by people like Leonardo da Vinci, who had actually designed for a humanoid robot. Now, nobody knows whether Leonardo da Vinci or his contemporaries had tried to build his design. But the drawings of these humanoids are even available today, and they are so detailed design that if somebody wants to recreate, he can. And these humanoids were supposed to sit up, move its arms, open its jaws, and those were a marvel of that time. Now, cutting a long story short and quickly jumping into our times, in 1651, there was this gentleman called Thomas Hobbes who published his book, Leviathan. And Leviathan was about a society which was ideal. There was no differences. And in the introduction of this book, Hobbes actually claims that it might be possible to build artificial animal. So the very idea of robotics or artificial intelligence, or what we now love to call humanoids or artificial human beings, was laid down in this book by Leviathan in 1651. And possibly this is why science historians, including George Dyson, refers to Thomas Hobbes as the patriarch of artificial intelligence. Actually, people who are aware of AI, many of you know that the term artificial intelligence was coined by John McCarthy. But most of the historians actually look at Thomas Hobbes as the father of artificial intelligence, because it was he who in his book in 1651 thought of an artificial animal. Now this is what Thomas Hobbes wrote in his book Leviathan. If you can see the picture of Thomas Hobbes that's being shown on your screens now. And the very important paragraph from this book I have quoted here. He says, life is but a motion of limbs. So why may we not say that all automata? And he compares automata to engines. So he thinks that the human life is an engine that moves themselves. In a mechanical system, it could be springs and wheels. And why can't these things have an artificial life? And that is what he had dreamt of. And taking this dream forward is a very interesting French gentleman and many others who constructed actual automata that moved in startlingly lifelike ways. They really built automatas like this. And possibly the most sophisticated of them was by the French gentleman who built a mechanical duck. Now, in a minute, I will show you the duck. This duck could quack, flap its wings, pedal, drink, and eat and digest grains. So it would take grains, and as it crushed these grains, energy from the springs would be stored for the duck to carry on its other activities. And this was a marvel of the day. So it was so sophisticated that it looked at the real duck. So Jacques de Vanquet's son is the one who built this masterpiece. And possibly this is one of the first artificial animals that Hobbes and others had dreamt of. Now, French was also a very pioneering state in the area of automated machines. French silk weaver and inventor Joseph Marie Jacquard actually invented the automated loom. And these automated looms were controlled by punch cards. So they were the first numerically controlled machines in 1801. Within a decade, it was mass produced and in great use across Europe. So that is how mechanically manufactured cloth took over the whole world. And rest is history, how they came to India and also took over the trade of our indigenous weavers and farmers. But then, looking at it from a different angle, this was way beyond its time. 1801, somebody is making an automated loom that's controlled by punch cards. And these punch cards, if you look at the history of computing, is nothing but what we today call computer numerical control machines. Robots equally was driven by not only these dreamers who built things, but also people who had looked at them in science fiction. And possibly the most interesting of them was this wonderful Wizard of Oz science fiction creation. Here, the wonderful Wizard of Oz is talking of a mechanical man who is in search of a heart. And even though people had realized that we could have mechanical embodiment, people were still very sure of not having mechanical embodiment of emotions. That's why they were thinking of such interesting creations in science fiction. Possibly the most interesting of the stories in science fiction is the one by the brothers Joseph and Carl. So that's called the Rossum's Universal Robots. Joseph Kapak, he wrote a short story, Opelek, that described automatons. Now I should tell you here, and this is your take-home point. Up to 1920, when Rossum's Universal Robots was written, the term robot was not there in the literature. So until 1920, people used the term automatons to describe anything that could do things on its own. Joseph's brother, Kurt, he introduced the term robot for the first time in the play Rossum's Universal Robots. So the story is about a mad scientist. That's not what is important for us. But what is important for us is that in around 1920 itself, they could dream that man had acquired the technology and intelligence to create life. And artificial humans as perfect workers is what is conceived in that play. Sorry. So they were talking of a tireless laborer. And this is what was moving the story of robotics forward. Science fiction moving real development. So the term robots that was introduced by Karl Kapak is coming from a Czechoslovakian word called robota, which means forced labor or servitude. Now, Karl Kapak, though he wrote Rossum's Universal Robots, actually didn't coin the term. But it was Joseph who had actually given this term called robot. And as I was telling you, your first take home today is that prior to 1920, the term automaton was used. It was only in 1920 for the first time that the term robot was introduced into the literature. Robotics, for that matter, was still missing. Nobody knew what robotics is until Isaac Asimov, another science fiction writer, wrote a series of stories depicting robots throughout the 1940s. And he gave what are called the laws of robotics, the laws that these robots obey. And he used the word robotics in a short story called Run Around for the first time. So 1920, robot term comes into the literature. 1942, the word robotics is introduced to us. And today, we tend to use it, and it has become so ubiquitous, it has become part of our daily living. So let's quickly do this history by just looking at a graph and just looking at 3 or 4 important points. So I will now only present you a couple of significant moments in the history of robotics. This is in the interest of doing certain more interesting things in the later part of the talk, because I have only 1.5 hours to do this. So we'll quickly look at very interesting years in the development of robotics. Neither I am saying that things that are not covered was not important, but what I'm rather saying is the things that I pinpoint here were actually the turning points in the history of robotics. So number one, 1942 is a very important year in the history of robotics. 1962, another turning point in the story of robots and robotics. And of course, 1970, which ushers in the new era of robotics, what we call the intelligent robots. So one after another, I will cover for you the story. But if you could see the photographs displayed on your screen, 1942 shows a small autonomous robot. 1962 shows our first industrial robot, and 1970 shows our first intelligent robot. So these were the turning points. But then, if you look at the history and really want to understand which is the most significant moment, and we will look at them one after another and try to name each of them as first, second, or third. So in 1948, what happened was we had a neurologist, a neuroscientist, Dr. W. Gray Walter, and he was interested in robots that could model brain functions. In the process, he built 2 small robots, which were called tortoises, and he named them Elmer and Elsie. Now, Elmer and Elsie were marvel of the day, because as you recall, 1948, we do not even have, forget about ICs, we did not even have transistors. So these robots, they did not have any pre-programming. All they had was basic analog circuits, vacuum tubes, and a touch and light sensor. And they were so programmed that they could recharge their own batteries. They could go to the nearest socket to get themselves recharged if their energy was running out. And they could exhibit real intelligent behavior. However, this is only significant moment number 2. Because what happened in the 60s was far path-breaking and of more importance than Elmer and Elsie themselves. So let's look at what happened in the 60s. Here on your screens, we have 2 gentlemen, Engelberger and Debel. Joseph Engelberger, on your left, was an aerospace engineer, and he met George Debel, an entrepreneur, over a cup of coffee. And Joseph F. and Debel, they were discussing about a patent of getting a programmable manipulator, something like the human hand that could work as a mechanical system. So Engelberger immediately saw the potential of these great things, and they joined hands to form the first robotics company in the history. So Joseph Engelberger saw the potential, and with George Dable, they found Unimation, the world's first robot maker. Unimation as a company did come, but then nobody bought these robots because no one knew at that point of time what to do with this mechanical arm that could be controlled at each joint and allowed to do things better than a human hand. Until they really poised their solution as one that could take out hot casts from the foundry. And this is when the first robot was bought by General Motors. And General Motors became the first company to install Unimate, which was involved in extracting hot parts from a die casting machine. And that was a dangerous job for a human worker. And that is what robots were used for. So robot in its first application was sold as something that could protect a human from taking up a dangerous job. And that was when General Motors brought this first robot called Unimate. And this is significant moment number one in the history of robotics. Today, robot is not only used for such dangerous jobs, but also for repetitive mundane jobs like welding, spot welding, or creating even spots on an integrated circuit. So today robots has come a big way into the industry, but it was in 1962, General Motors was the first company to install a robot. And that's significant moment number one in the history of robotics. 1970s saw a turning point in the way robots and robotics was looked at. Robotics was now not looked at as just a simple machine, but with the progress in artificial intelligence, people started to look at artificial intelligence as a part of robotics. So people were talking of robots which were intelligent in its own sense. And late 1960s and early 70s, researchers at the Stanford Research Institute, they started working on an intelligent robot that could really look at things on its own, decide and take decisions. So the ability to reason was built into, but then this robot was supposed to deliver cokes of canes to different offices in one floor. It took quite a long time to do the decision because computing was very less at that point of time. So computing power was really less at that point of time. So it took a lot of time to make a decision. And when it did move, it used to shake quite a bit. And therefore they call this intelligent robot shaky. But whatever it is, shaky is the first intelligent robot that we see in the history of robotics. And that's significant moment number three. World's first mobile autonomous robot, which is programmable, number one. Number two, it had three different layers of doing things. One, the mundane electronics of moving, turning, navigating. Then the second interesting layer of building routines out of its information. And finally, in higher order planning that was possible. So shaky was a turning point, not only in the history of robotics, but in the history of artificial intelligence and robotics being woven together, being looked at as one and the same story. So I love to see robotics and AI not separately. Robotics requires a lot of AI techniques, and to further AI techniques, you need a lot of automated machines, which is what we call as a robot. So these are the very important significant moments, moment 1, moment 2, and moment 3. And this is your take home 2 from this lecture. So remember, take home 1 was about the idea of the term robot being introduced in 1920, robotics being introduced in 1940s. And then your take home 2 is about the significant moments in the history of robotics. The most significant of them being Unimate being bought by General Motors in 1962 for die casting, and then Shaky the intelligent robot, as also Elmer and Elsie, that was developed in 1948. So let us now leave behind history and move to more interesting things on what is a robot. Now, if you go out and ask today the general public what a robot is, you'll have so many definitions, and many of them so poor, and many of them so very out of this world. This is because of the hype that is created around this word by media, and also at times by people who do not understand what a robot is. So let me clarify for you what is a robot. If you ask different people, you have different answers, because robotics is looked at different ways by different groups of people working on it. And it is like the proverbial elephant. Somebody looks at the tail and thinks it's a rope. Somebody at its ears and thinks it's a fan. Let us try to demystify this word. If you look at the dictionary meaning of a robot, the Merriam-Webster dictionary defines a robot as a machine that looks and acts like a human being. But that's not anywhere near to what the robots we are dealing with as mechanical engineers. I like Merriam-Webster's second definition, which says an inefficient but insensitive person is a robot. So over my 30 years of career, all my bosses have been robots. That way, okay? So that's something that all of us feel. But what is more interesting is their third definition. A robot is a device that automatically performs repetitive tasks. So even a dictionary is not very sure on what's a robot. The Oxford American Dictionary, on the other hand, defines a robot as a machine capable of carrying out a complex series of actions automatically, spatially, one programmed by a computer. Now, because of these conflicts in the definition of robot, as mechanical engineers, if we really want to move ahead in robot and robotics, we cannot take these definitions. So we have to look at certain things that are more interesting than this. So what is taken as a definition of robots is the Robotic Institute of America definition. So according to the Robotic Institute of America, a robot is a reprogrammable, multifunctional. So these are the keywords. It has to be reprogrammable, programmed over and over again, multifunctional manipulator, designed to move material, parts, tools, spacious devices. That's not very important. What is important is the last phrase again, for the performance of a variety of tasks. So anything that's reprogrammable, like your microwave, is that a robot? According to the RIA definition, it is not, because it's not multifunctional, or it cannot do variety of tasks. If it was capable of a variety of tasks, then it would be definitely a robot. So according to RIA, anything that's reprogrammable, anything that's multifunctional for the performance of a variety of tasks is a robot. But then the Japanese do not agree to this definition. According to the Japanese Industrial Robot Association, there is not one, but a series of different types of mechanical systems controlled by electronics, which are electromechanical in some sense, or the more recent catchword being mechatronics in some sense, is a robot. So according to JIRA, we have manipulators, which are manual, sequential, or programmable, which is a robot. I will come to each of them one by one. Then we have numerically controlled systems, like our CNC machine is a robot according to the Japanese Industrial Robot Association. Anything that has sensory feedback into its control loop, those are also robots according to JIRA. So they are called sensate robots. Anything that adapts its control and operation, so any adaptive control system, electromechanical system, is a robot. Smart machines, including your smartphone, intelligent mechatronic systems, they are all robots. So Japanese Industrial Robot Association has the following 6 classifications for robots: manipulators, numerically controlled, sensate, adaptive, smart, intelligent mechatronic systems. So manipulators would be manual, machine slaves to human operators, or sequential, devices that perform a series of tasks in the same sequence every time they are activated. And programmable, an assembly line robot arm. So even the JCB machines that you see working on roadsides, according to JIRA classification, are manual manipulators. Then we have numerical control machines like the spot welders. These are robots according to JIRA classification. Then robots that incorporate sensory feedback into their circuitry, like anything that has touch sensors, proximity sensors, vision, and so forth, are robots. And in fact, the helpmate trackless robotic hospital courier system, or many states in this pandemic have come up with small mobile systems that could go in and deliver food in quarantine centers. These are actually robots that incorporate sensory feedback. Then we have adaptive robots, robots that can change the way they function in response to their environment. So here I have shown you a very interesting robot that's called Casper, or it's kinesis and synchronization personal assistant robotics. It's a child-sized humanoid robot. It's like a toy, but actually it's a robot according to JIRA classification because it adapts. And these type of robots are used for social interaction skills in children with autism. Hello. I can hear somebody wanting to speak. Is there some question? Hello.
Please,
Hello.
please mute others, please. Please mute others.
Okay, sir. Okay, sir. Sure, sure.
Okay. I thought there was a question. Oh, no, there was a baby. Okay, no problem.
There was some.
He must be. Yeah.
Sorry for inconvenience, sir. Please continue, sir. Sorry for inconvenience.
No problem at all. Don't be sorry. I'm enjoying it. Don't worry at all.
Oh,
Yeah. No sorry. No problem. Okay. So then we had robots that are considered to possess AI. Those are called smart robots according to Zira classification. And I had intelligent mechatronic systems that refers to intersection of mechanical, electrical, computer control. So any intelligent mechatronic system that you can see on a car, according to Jira, is a robot. So I want to emphasize at this point of time that there is a huge distinction from the American view and the Japanese view on what is be a robot. For the Americans, anything which is multi-programmable, multifunctional for variety of tasks would be a robot. But for Jira, even very small sensory feedback systems, very interesting adaptive control systems, or even intelligent mechatronic systems would be robots for them. So that you got to remember when you're moving into robotics. So what is a robot, or what are the different aspects of robotics? So whenever we are talking of robots, we need to understand that we are talking of joints and links. Joints, those are allowing us some degrees of freedom with respect to one axis, with respect to the other, and links are ones that carry motion from one point to motion to a different point. Like this is a link here that carries this translatory motion from this point here to this point at the other end. So that's what robots are made of. And we have drives, actuators, and sensors. So drives and actuators, they convert energy to mechanical form, and sensors are actually transducers that convert a physical stimulus from one form into more useful form. So sensors could be of two important types, and this is your take home for, or your third take home today. Whenever we are talking of robotics, we talk of two types of sensors. One called the proprioceptors. The proprioceptors are sensors in a robot that measures the kinematic and dynamic parameters of the robot itself. So when I'm thinking of knowing how I am with my own frame, then I'm talking of proprioception. Whereas exteroceptors, these are sensors that sense the environment in order to estimate the location, position, as well as force interaction with the environment. So whenever I'm talking of sensing in robot, I am either talking of proprioception, which is sensing my own kinematic and dynamic parameters for myself, or exteroception, sensing the environment in order to estimate my own location, position, or my interaction with the environment. So this is something that we must be very much aware of when we are talking of robotic sensing. As for kinematics and dynamics, this being a group of people from mechanical engineering predominantly, I will not even discuss this here. All of you know what kinematics is. It's the study of position, velocity, acceleration, or higher order derivatives of position variable, but we do not consider force. So we can think of actually doing a lot of robotic analysis without considering force. And for that, we just need to understand motion of how one link is varying with the other. When I'm talking of dynamics, I study forces required at the joints to cause motion of the end effector. So robotics can be studied only to understand motion, then we are doing kinematics. Robotics can be studied to only understand forces at joints to cause motion, then it is dynamics. So that's an aspect of robotics. But what is the most interesting and exciting aspect of robotics is about planning and control. How does a robot plan and control things? So in order to plan and control things, we do integration of multimodal sensory information. So you have sensory information in robots, which little while ago I told you could be proprioception or exteroception. If you are trying to really understand robotics, then you have to do integration of this multimodal sensory information. And then and only then you could be doing planning. Where does AI come in? AI comes in when I'm talking of interaction with the real world. That is, I try to perceive, understand, or act. For example, speech recognition or image understanding. AI comes in when I am thinking of reasoning and planning, that is involving modeling the external world, planning and decision making, and that is where AI comes in. And I deal with unexpected problems and uncertainties. That means whenever I am interacting with the real world, whenever I am reasoning and planning, and whenever I am learning and adapting, this is where artificial intelligence, or the more catchy term today, the subset of AI called machine learning, that comes in. So what I'm trying to tell you is that when I'm talking of robotics, we have hardcore mechanical engineering like kinematics and dynamics. We have real signal processing like sensing, that includes proprioception and exteroception. And we have applications of this to make things intelligent. So we have AI, interaction with real world, reasoning and planning, learning and adaptation. So now in the remainder of this talk, I will focus on what is happening in the world of robotics and how are we moving forward, or what is the research that we are looking at in the 5-10 years to come. So according to Gartner, which is a technology forecast company, they published this as paper in 2018, and which I have on your screens if you can see. It says emerging technologies in the next 5 years in the area of robotics. We would see a lot of chatbots. Okay. Now, in fact, chatbots have become part of our life. We have Alexa already there as a chatbot. We would see a lot of algorithms and advanced analytics. Now, these two things have actually moved in. What is more interesting, in the next 5 years, we will see a lot of surgical robots in play. So robots that do surgery. I will come to this in more detail in my slides in a minute or two. But I would love to emphasize here that many sophisticated surgeries, which is not possible at a level of dexterity by a human surgeon, is actually done by robots. And surgical robots actually augment the capabilities of the human surgeon instead of replacing it. That's what is important. Warehousing robots, pick and place robots for light assembly, supply chain automatons, they would become really functional. Cost would become low, and we would see a lot of robotics in warehouse. In fact, Alibaba, Flipkart, and Amazon has moved towards really putting robots for pick and place warehousing tasks. Drones, you see, are becoming popular. That's what Gartner forecasted. But then what is more interesting is there will be submersible drones, underwater drones coming up as well. So people who are doing drones, anybody here today, please think of really getting these, is not fly in the air, but go underwater, and you would be at the tip of the technology curve. So where are we heading in this story of robots and robotics that I started with looking at Aristotle's The Politics from 300 BC? Many of you can now see the car that I have shown on your screens and know about this car. This is Model S, as from Tesla. Now, according to Elon Musk itself, the CEO of Tesla, Model S is not a car, but a sophisticated computer on wheels. Why is it so? Because it has not less than 540 sensors. So we have forward-looking cameras mounted in front of the rear view mirror. We have radar that sits below the nose cone. We have 12 ultrasonic sensors, and they provide 360-degree vision. Then information on the camera is supplemented by information from the GPS. Now, that's the machine of the future. According to Timothy Chow, a professor who looks at what I call precision engineering, he says that the machine of the future would definitely be an assembly of parts like gears. They cannot take away gears. Gears would be there, okay? And electronics. But that would not be all. The machine of the future is also an integrated collection of sensors and actuators that would be connected by software. Now, this is what we people tend to loosely call the Internet of Things. But this is beyond Internet of Things. It is about connecting sensors, actuators via software of any mechanical system that's running. Okay? And that is where we as mechanical engineers have a huge role to play. So if you really look at robotics vis-a-vis where we are heading today in terms of Internet of Things or in terms of Industry 4.0, we would see robotics and automation playing brilliant role in at least three spheres: robotics in manufacturing, space robotics, and service robotics. Robotics in manufacturing is about robot material handling, robotic welding, assembly operation, or processing. Space robotics is more to do with robotic agent, robotic assistant, or what is commonly called cobots, that is collaborative robots that exist with the human. Similar is the case with service robots. We would be having very soon industrial service robots being replaced by domestic service robots, and scientific service robots is already a very interesting story where robots are helping in surgery, robots are helping in many biopharmaceutical companies. One application of robotics, which is going to come in a big way in the next 5 to 10 years, is in medical robotics. In medical robotics, we will see a huge progress in terms of robotic surgery, in terms of rehabilitation and assistive robotics, and in terms of revolutionizing point of care support or revolutionizing healthcare. So the emphasis would no longer be on treating diseases, but it would be on living healthy. And the living healthy will be taken care of by many offshoots of robotic technology. One area which is coming in a big way, and I'm afraid this may take over most of what is done good in robotics, is the entertainment robotics. Of this, the only thing that I like, and that is what I have highlighted here, is the Robo Cup. The Robo Cup is an international competition of robotic football with the ambitious official motto that by 2050, there will be a team of fully autonomous humanoid robots that can win against the human world football champion. And this is going in a big way in robotics. Now let me focus one by one on robotics and automation innovation that's coming in a one big way. One is the area of automated monitoring. Automated monitoring is about using robotic technologies to monitor vitals of patients and communicate it to doctors or communicate it to nurses so that they can take up what is there. So this is done by a technology called Internet of Things, which many of you may be aware. So Internet of Things is about giving identification to each machine or each element of a system that then is sensing the environment or the system itself. So it could be proprioception or exteroception. The sensing is then being communicated. The communication is then being computed over a lot of systems on the cloud. And then important services are being rendered and meaningful information is extracted for the next task. So this idea of automated monitoring is not a fiction. Sensium Vitals is a company in Europe which has made it really look so simple in most of the European hospitals. There is not a nurse coming to your room every hour. Rather, you are being monitored as a patient through robotic technology of information of being communicated and services provided thereof. Another very interesting idea that even companies in India have looked at very closely is the idea of digital twins. As mechanical engineers, we need to be very proud that Indian company Voltas has put this into operation into their day-to-day working in India itself. What is a digital twin? A digital twin is a digital representation of the real world object. So it's not a simple CAD model. It's a CAD model, it's a finite element analysis model, it's a physics model, it's a statistical model, it's a machine learning model, it's an AI model. So it is an avatar of the machine in the virtual world. And as you operate the machine year after year and get new data to understand how the machine will behave, you do this in the virtual world. You generate a lot of operational data. And you then create what would be the maintenance history of this machine and follow this up in the real world. So you do not actually do predictive maintenance. It is more than predictive in the sense that you actually see how it's going to operate and you really create your maintenance history. So digital twins are being applied by Voltas for their chillers that they have put in different industrial sectors. And they monitor these chillers by using digital twin technology. Rather than putting engineers looking at the chillers in the plants and trying to do preventive maintenance, they have made digital twins of this, operate these models, get the operational history, create the maintenance history, and have put this back to the plant. So this is one technology which is robotics in its most beautiful form, or in the sense that we are able to save a lot of manpower hours, a lot of downtime by using this type of technology. Now, one thing that has fascinated me is the progress that robotic surgery has made in robotics as a field of study or area. One company that is the world leader is Da Vinci robots. So in order to understand robotic surgery's progress over the years, let us quickly look at the history of surgery. So surgery in the Middle Ages is in Europe, there was marked regression in surgical knowledge. In fact, the village barber was the surgeon who would perform the usual functions of a barber as well as a surgical operation. But Asia, for that matter, was home to many talented brain surgeons. And in fact, this Islamic school of brain surgery was one that flourished over the years. Now, if you look at surgery as a modern medical technology, you should understand that the idea of analgesics, antibiotics, anticoagulants, antiseptics, and anesthetics, these give rise to modern surgery. But people were not happy. Okay, they were not happy because still after surgery there was a scar that was left on your body. So they were still looking for tools and approaches for scarless surgery. And that is what gave rise to what we today call laparoscopic surgery or minimally invasive surgery. So minimally invasive surgery, where you have endoscopic instruments going into your body via small holes, is a marvel of mechanical kinematic synthesis. You should realize this, that any minimally invasive surgery, any laparoscopic surgical tool is actually a mechanical system, a kinematic synthesis of a system, which is part and partial of not only robotics, but of mechanical engineering. Minimally invasive surgery was going on very nice, but people still didn't like this idea because they were still relying on techniques that would have to really go inside and look at it and open it sometimes. So people thought of putting computers together with endoscopic surgery, and medical imaging and endoscopic instruments were together put, and they give rise to what is today more fancifully called computer assisted surgery. In computer assisted surgery, you have a robot that is assisting you, but that robot is driven by a number of computer assistants derived from offline diagnosis. So you have CT scan, or you have MRI images, or many other things, and a robot is assisting the surgeon and in minimally invasive surgery. And that process is computer assisted surgery. So in computer assisted surgery, the surgeon is not working on traditional mental registration. Rather, he has multimodal data integration and via computer coming to him via a robot. And that's played here in augmented reality. And then he works on the patient. Beyond this, there were people who really looked at robotic surgery, and the first of these were two surgeons at University of California, Bill Berger and Howard Park. And they began to wonder if you could use a robot to machine the cavity for the hip implant, and they really put it on a dog in 1990. And the first of the human surgery by a robot was performed around 1992. And as I told you before, today, a robot company, Da Vinci, is the success story. You may be already aware, but let me tell you, for completeness sake, that this is not a fiction. Even a country of our size and with the sophistication of surgeons we have even small towns and cities now with robot surgery facility. This is precisely because many augmentation of the human surgeon is possible, because like taking a very small slice of a kidney may not be possible by a human surgeon, but by a robot, given well coordinated mapping of the human to the coordinates of the robot system, such a slice is possible. And therefore, even small towns and cities have now adopted robot surgeons. Moving beyond, wireless technology has come together with robotics to even create a field which is called natural orifice surgery. Here, you do not even make a hole. You send a robot via an existing natural orifice, like your mouth, into the human body, control the motion of the robot via wireless sensor network over the body, allow the robot to do its surgery, get it loaded itself, and come back again by the natural orifice. Now, this is a dream that would be very true. It will be true very soon. But till now, wireless capsules being sent inside to do surgery is under trials. So in terms of rehabilitation and assistive robotics, 3D printing, brain-computer interfaces, rehabilitation, point-of-care diagnostics are doing a great thing, which I will not go into much detail. But let's look at what is happening in terms of social robotics. So interaction with human or other physical embodied agents is usually laid down social behavior. So a new entrant to these fields are robots that are seen as teammates. So human interactive robots leading to the birth of social robotics is one current trend. Another is biomimetics, which is my own area. So I tend to get carried away. That's why I'll just talk of one line here about biomimetics. What we do is copy nature, define what robots are from nature itself. So biomimicry is about studying the nature's design and processes in search of inspiration. So if you are looking to design a flying machine, I will look for a bird and copy the mechanisms of the bird into it. So that's biomimicry. You copy not only the geometry, but also the functionality. So as I was telling you the story of the wireless capsule being sent inside, if you want a capsule that could swim and run, then you would copy a salamander, which is something that runs and swims equally well in a given territory. So you would rather have a machine that swims and runs at the same speed, both on land and in water. So that is what we do in terms of biomimicry. It's also about really looking at the human body and trying to understand how our skeletal-muscular system works so that we recreate an electromechanical system. So we look at how the brain works, how it controls the spinal cord, how the different muscles are controlled via the brain. So we look at electroencephalogram, electromyogram to adapt an adaptive system into our designs. So that's about biomimetics and biomimicry. That's one area of development, and these are things that's been done in my lab. I will now come to other interesting things, which is about cloud robotics. So the only thing that I've shown you for my lab is the biomimicry, okay? So don't get carried away. The other thing that's more interesting is cloud robotics, which is robotics with very less computing power on its own, but communicating to a cloud and doing most of the decision making on the cloud, passing it on to systems to just recreate the hardcore electronics. And the story that I was telling you about the digital twin for Walter's precision chillers, now that's a success story of cloud robotics, because they really looked at this digital twin technology. They really looked at the Internet of Things and really developed this whole idea of using digital twins, IoT, and cloud to create this success story. And it is a really proud moment for India, because Voltas is a Tata company, as you know, a completely India company, which is really doing this digital twin and plus IoT plus cloud, and is a case study in a very interesting book by Timothy Chow called Precision Engineering. So Precision Engineering, one chapter is devoted to Walter's precision chillers. If you look at that book, it would be really a good study if you're interested in what is precision engineering and using robotics. Fetch mobile platforms and another success story using clouds. So let us now spend some time in understanding what is the future direction of robotics? Now, as I was telling you the story of robotics, the idea of robots and robotics grew out of dreams and dreamers trying to really understand or trying to really look at systems that would be in place that would take away the social inequalities. So it would bring in equality in the social strata. One thing that robotics has not done up till now is that it has not been able to really eliminate this social divide. What robotics has brought, on the other hand, is more social divide. Like today, we have people who have smartphones with 14 to 18 sensors in it, able to control their microwave because of developments in robotics, sitting in their car, and others who are devoid of such technology. One thing that the future holds in robotics is the idea of embodied cognition, where machines, any machine that you have, would have cognition built into it. So cognition is the way we really exhibit rational behavior as human beings. So rather than sensor-driven smart robots, we have paradigms of embodied cognition. That means paradigms where electromechanical systems have the capability to do rational thinking that could define the design of robots in the near future. So models from cognitive science and neuropsychology could be the basis for robotics in years to come. And at the genesis of all of this lies the very idea that robots would be able to learn from human beings and then work forward. And this is why machine learning is becoming a very important area within AI and robotics in particular. So it's not that embodied cognition has not been looked into. On your screens now, I have shown you a small robot called Neo, which is a French robot with complete embodied cognition. So it has voice synthesis, it has ability to really understand emotions, it has a really prehensile hands, swappable head, okay, a lot of degrees of freedom, and it could really behave as a cognitive co-worker. Another very interesting story on embodied cognition is the ICUP. Many of you may have heard of ICUP. The ICUP is a humanoid robot that's developed as part of the European Union project on RoboCup. Now, ICUP is with 53 motors that can move heads, arms, heads. And most interesting, ICUP can see, hear, and has proprioception. Now, the most important thing about ICUP is that ICUP has been developed as a system that could learn things on its own. So here, if the video is working on your screen, you could see ICUP crawling. And this very crawling motion that ICUP is recreating has been learned by watching babies crawl. It has not been pre-programmed. And that is what embodied cognition is. You would not pre-program things. You would allow the behavior to be recreated by what are called cognitive architectures being built into the control system. So that's the beauty of embodied cognition. The final thing that I want to really talk of is the idea of synthetic biology. Now, you must have heard of John von Neumann, who had put in this idea of different architectures for computing. Von Neumann was also the first to put forward a proposal for non-biological self-replicating system. That is, a system that could have self-assembly and self-replication. It could really replicate on its own, and it could really assemble if required. So if you have a car, let's say, and one of the tire is flat, the car should have the capability to replace the flat tire, okay, and move forward. And if one of the tire is really going to drain, it has to be thrown away. It should be able to get the new tire built on its own. That's what is the idea of self-assembly and self-replication. And this idea has got fillip from the emergence of what is called synthetic biology. So synthetic biology is about design and construction of novel artificial biological pathways, organisms or devices. And that is the future of robotics today. So to finally conclude my talk, let me take you through the journey that we have covered in almost 1 hour and 25 minutes. We started with the story of Aristotle dreaming of a society where there would be machines that could play music, there would be machines that could really weave things. And then very quickly in the 1801 itself, Jacquard coming up with the loom, which could weave based on commands that you give via punch cards. And then many science fiction writers pushing our dream further, bringing in the term itself, Carl and Joseph Kappak bringing in the term itself, robot, Isaac Asimov bringing the term robotics for us. And three very interesting points in the history pushing our robotic journey forward. One, the idea of Unimation Inc., the first robotics company, and General Motors buying it for die casting work in '62. And two tortoises created by Gray Walter in '48. And the first intelligent robot, Shaky, at Stanford Research, pushing robotics history forward. But what has it led us to is the robots coming out of the industrial application into more non-conventional uses. Like today, robots are used not only in the industry, but in every sphere of life. And therefore, the robotics definition or the definition of robot from the Robotics Institute of America looks to be more restrictive. And the JIRA classification of robots looks to be more encompassing to the very idea of robots that we see today. The JIRA classification, even looking at smart systems, even looking at intelligent mechatronic systems to be robots, is what we have actually embraced. There has been a lot of progress in robotics in terms of medical robotics, in terms of service robotics, and also in terms of social entertainment robotics, which for brevity and for the sake of just introduction here, I have named them but not completely covered in detail. You may be aware of many social entertainment robots or that are there. But the emphasis is slowly now moving away from just being a group of sensors or feedback control systems. What we are today looking at is robots that could be actually talking of cognitive embodiment. That means the whole human brain, the way rational behavior is exhibited by the human being part of the robot. The most interesting success stories of embodied cognition are the Neo robot from French and the iCup, which is a 3.5-year-old robotic baby from European Union, which learns by observing humans. They are not pre-programmed. They learn by observing humans and exhibit human-like behavior. One thing that's the future in robotics and push in a great way is the idea of synthetic biology, that is the design and construction of artificial biological pathways, organisms or devices that we will see in the near future. Thank you very much for your kind attention. I will now stop the slides share and maybe we can continue further. Thank you very much.
Thank you, sir. Thank you very much, sir. Your sharing of the valuable knowledge.
So, dear participants, if there are any questions, you may please ask from our honorable speaker. Now you can unmute yourself and can you ask your questions? Any questions, please?
No, sir.
I think, okay. You can write your question in chat box also. Okay, I think.
Sir, your lecture was so smartly described and explained, and every aspects of the history of robotics, how it was started, and the present and current scenario, and what will be the future direction. I think it is explained in so well manner that there is no scope of question. I think our participants has listened this very.
Thank you very much. So I hope I was clear in my voice because we have a very bad connectivity problem today. So anyway.
Yes, sir. Yes,
Yes,
sir. It was very nice talk, and thank you very much. I think it was the really a marvel takeaway in this STC, sir. Thank you very much for this sharing your valuable knowledge. Thank you very much, sir.
So we are
Thank you.
we are receiving very good feedback in chat box, and the participants are sharing that the lecture was very informative and well explained. So on behalf of JC Bose University of Science and Technology YMCA Faridabad, we are very thankful to you, sir, for your this valuable time.
Thank you very much. It was my pleasure talking to all of you. Wish you all a very brilliant success in the days ahead. Thank you.
Thank you very much, sir.
Can I now leave the meeting?
Yes, sir. Yes, sir. Yes, sir.
So Vimlesh, the next session, I think someone can
So the our next session will be start on 12 p.m.
12 p.m. Okay, okay. So next
Okay.
coordinator will be joining, right?
Yeah. So next coordinator will be joining that session. Thank you for joining as a coordinator in the session, sir. Thank you.
Thank you, Vimlesh.
Okay. Yes, Mr. Pradeep Singh ji, is there any point? Please unmute yourself. You can say this. Pradeep Singh. Pradeep Singh ji, you have raised your hand. Is there any? Okay. Thank you. No points. Okay. Thank you all. I hope to join you on 11:55 a.m. Please join 5 minutes before the session because our speakers are so punctual. They join on time and I wish to meet at 11:50 a.m. Thank you. Thank you for joining this session.